Hey everyone! Thanks for joining us for the next session of our Spotlight on GitHub Advanced Security series. GHAS without the guesswork, the streamlined enablement with Modus Create. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speaker for today. Sean, thank you so much for joining us.
Hey everyone, thank you for joining us today for GHAS Without the Guesswork, enablement with Modus Create, and thank you to Microsoft and the GitHub teams for inviting me to speak with you all today. So before we begin, I do have a few quick questions for the group, and you can post your answer in the chat or just note them to yourself, absolutely voluntary. But the first one is, on a scale of 1 to 5, with 1 being the least and 5 being the most, how engaged are you with GitHub Advanced Security currently? Give a moment if anybody wants to throw that in there. And the second question is, what are 2 challenges you're trying to solve for in your organization? Like, a lot of what we do is problem solving, right? And then the third question here is, what is 1 outcome that you'd like to see today? All right. So moving along then, in this session, we're going to cover a few topics. The first is the OWASP DevSecOps maturity model as it pertains to Enable. The DSOM helps us to translate security features into real maturity. So it's not really just about flipping switches, it's about knowing where we are and where we are headed. The second topic we're going to cover is GitHub Advanced Security itself, also known as GHAS. Now, these are the built-in capabilities GitHub gives us to detect, prevent, and manage security risks across repositories. And the third is how we can use expert guidance and scripting to reduce friction. And really, this is where we move from theory into practice, using automation and guidance as the grease in the gears, reducing friction and ensuring security fits the way teams actually work. So before we get started, I do want to tell you a little bit about myself, so I'm not just some stranger on the screen. My name is Sean Clayton, and this is actually my first time speaking at the Reactor series, so I'm super excited today. Outside of this virtual setting, I've helped to run workshops at B-Sides Las Vegas, helped to organize B-Sides Connecticut. So B-Sides are locally run InfoSec conferences, if you're not already familiar. Aside from that, I've taught biology at the high school level, hence the questions at the beginning. It's just something that I've worked into my own repertoire. I'm a senior principal security engineer at Modus Create, which basically means I manage teams responsible for GHAS enablement and other DevSecOps engagements. Now, in addition to formally teaching, I'm a veteran of the United States Army, and I'm pretty passionate about all the nerdy things, so making the transition from biology to cybersecurity wasn't so much a leap as a hop, skip, and a jump. Outside of the tech space, I practice Brazilian Jiu-Jitsu, or BJJ, for those not in the know, and enjoy spending time with my family doing lots of outdoorsy things. All right, so a quick overview about my employer, Modus Create. We're an end-to-end digital consulting platform who's been around since 2011. Our team is spread over 50 countries and handles work in several domains, including product development, digital operations, strategy and data, AI, and of course, platform cloud security. Within the security department, we do a lot of work in the Azure space as well as GitHub. We're well experienced in DevSecOps work and helping customers handle build systems in relation to monorepos. So if you're a Bazel shop, we'd really love to hear from you. Finally, Modus Create is a digital app and innovation partner with Microsoft and a GitHub Copilot launch partner. Okay, so that's really enough about me and Modus. Let's get into the meat of things and discuss streamlining GHAS enablement. So, adopting any new technology comes at the low price of learning how to adapt to that technology. And what I mean by that is that we need to learn how best to deploy it into our systems, understand the associated best practices, and have our devs not only buy in, but use the tech appropriately. This can be a bit of a learning curve because we don't always know what we don't know or even where to start. Now, with that in mind, let's take a look at that beginning. And we want to start with the problem, right? What do we want to solve for? Now, as many of you actually already know, modern software development is fast-paced, highly distributed, and increasingly dependent on open source components, which incidentally leads to excess tooling. Additionally, security vulnerabilities, misconfigurations, and compliance gaps, potentially due to that vibe coding that we all know and love, often go unnoticed until they become major risks. On top of this, each organization comes with its own complexities from CI/CD integrations to how source code is managed, meaning repo structure and deployment schedules. So there can be a lot of those what if scenario questions before even beginning the process of securing your environment, which in turn begs the question of where do we start? Now, why this matters is that security tools like those in GHAS help teams shift left and proactively close security gaps by prioritizing real risks while cutting through noise. This reduces technical debt by fixing vulnerabilities before they compound and ensures that security measures align with business needs by embedding security checks throughout the development lifecycle, where organizations can reduce the risk of security incidents, improve compliance with industry regulations, and build customer trust by demonstrating a strong security posture. Now, on the other hand, neglecting security can lead to mounting technical debt, costly breaches, and reputational damage, all of which are far more expensive to fix than preventing issues in the first place. So to expand on the topics that I mentioned previously, we'll provide a roadmap that covers overcoming that learning curve by aligning with frameworks like the DSOM, adopting best practices by leveraging GHAS, and streamlining enablement using open source automation and that guiding hand to reduce the guesswork in code scanning and the CI/CD integration. By the end of the session, you're going to leave with a clear roadmap to strengthen your security in your development pipelines, reducing risk while maintaining agility. Now, going back to our question of where even to begin, we generally need a roadmap for enablement to help preemptively answer those what-if types of questions. Every roadmap has a beginning, and ours begins with an assessment to see where we are at. Of course, if we want to improve our security posture, we need a framework that reveals gaps and guides progress. And that's really where the OWASP DSOM comes in. So just to explain really what exactly it is, and to summarize a previous webinar on the subject, the Open Web Application Security Project is a globally recognized nonprofit organization dedicated to improving software security that provides freely available resources, including security standards, best practices, and tools to help developers and organizations build secure applications. It's best known for projects like the OWASP ASVS or Application Security Verification Standard, the OWASP Top 10, and more recently, the OWASP Top 10 for LLMs, as well as frameworks like the DSOM or DevSecOps Maturity Model. Now, the DevSecOps Maturity Model, or DSOM, is an OWASP framework designed to help organizations assess and improve their security practices in DevOps environments. It provides structured guidance on embedding security into software development, helping teams measure maturity levels, and most importantly, drive continuous improvement. DSOM evaluates an organization's security posture across key areas of concern, and these include the following topics: culture and organization, design and architecture, build and deploy, and then operation and monitoring. Now, these areas help engineering teams systematically implement security best practices across the software development lifecycle, or SDLC. The DSOM, therefore, helps integrate security throughout the entire SDLC by measuring things like security awareness, security coding practices, static and dynamic analysis, and secrets management. By using GitHub security features, DevOps teams can map the DSOM principles directly into their CI/CD pipelines, ensuring security is an integral part of software delivery. Now, GitHub provides powerful security tools that align with DSOM framework, which means we can continually automate and continuously improve our security posture instead of relying on those ad hoc checks. Now, just to quickly go over, and we'll go a little deeper into this, but to go over quickly some of the features of GHAS, we have CodeQL for advanced static analysis, secret scanning for which detects exposed credentials, dependency graph and Dependabot identify vulnerable libraries and automate updates, security advisories track and address vulnerabilities, push protections prevent secrets from being committed even in the first place, and then security policy enforcement is done using things like branch protection and signed commits to enforce those standards across teams. Now, the real value here comes from how those tools align with DSOM's maturity areas. Now, for example, we have software composition analysis, which aligns with dependency graph and Dependabot, of course. Static and dynamic analysis tie back to CodeQL. Secrets management maps to secret scanning and push protection. Logging and monitoring is on full display with security logs in GitHub Advanced Security. And then security testing automation is enabled through the CI/CD pipeline via GitHub Actions. And here's where it gets really practical. We don't have to measure this manually. By using scripts against the GitHub API, organizations can continuously check whether their security settings align with DSOM. And that means checking repository security settings, verifying Dependabot updates and alerts are enabled, ensuring that CodeQL is active, auditing secret scanning and push protection settings, and monitoring security advisories and tracking for those vulnerabilities. And really the payoff here is that instead of a one-time assessment, you get continuous visibility into how your security posture measures up against the DSOM. And this makes it easier to track progress, close gaps, and enforce best practices at scale. Now, in short, when you align DSOM with GitHub security capabilities and automate the checks, you're not just improving tools, you're systematically raising your organization's security maturity, reducing risk, and embedding security seamlessly into the way you deliver software. And if you'd like to learn more about how to shift left with the DSOM and GitHub, scan this QR code and you can be taken to our more comprehensive talk on the subject. All right, now that we've talked about how GitHub Advanced Security maps to the DSOM, I do want to touch on GHAS features just to have it fresh in our minds. GitHub Advanced Security is a set of security features built directly into GitHub. It helps developers detect, prevent, and remediate vulnerabilities throughout the SDLC without disrupting workflows. GHAS also integrates with third-party tools, making it flexible enough to fit into any environment. So let's take a look at the key features from a high level, starting with CodeQL. CodeQL performs static analysis on source code to detect vulnerabilities and supports a wide range of languages from C++ to Ruby, Python, and JavaScript. At its core, CodeQL is a powerful query-based engine that treats code as data and surfaces those vulnerabilities early, giving developers the chance to fix issues before the code is deployed, which is super important, right? What's great here is that GHAS doesn't lock you in. If you're using other tools like Trivy or Psalm that generate Serif output, you can integrate those results right into GitHub security dashboards. And to make remediation even faster, through the power of GitHub Copilot, the autofix feature can automatically create pull requests with the suggested patches, helping teams cut down on time to fix and keep development moving securely. And moving on to secret scanning, which in GitHub is designed to catch hard-coded credentials before they become a problem. It automatically detects patterns that match known providers like Azure or AWS keys, as well as non-provider types such as private keys or tokens. And when a potential secret is found, GitHub doesn't just flag it, it actually validates whether the secret is active and checks if it's been exposed in any known public breaches. And when you enable push protection, GitHub goes one step further by preventing developers from committing those secrets in the first place, stopping sensitive data from ever entering the codebase. Combined with custom pattern support, these capabilities give teams both the flexibility and protection, dramatically reducing the risk of credential leaks and the downstream security incidents that often follow. GitHub's dependency graph automatically maps out all of the software dependencies, including transitive ones. And those are those dependencies of dependencies. So those things that like you may not necessarily realize are in your dependency chain. And that's done at the repository level, which gives teams visibility into what's being used and where. Dependabot itself alerts you when vulnerabilities are discovered, where Dependabot security updates can even automate the patching process by opening pull requests and fixes. Together, these features not only simplify dependency management, but also provide an important layer of protection against those supply chain attacks, which helps you to stay ahead of the emerging risks without adding extra burden on developers. And lastly, security policies and alerts. These features allow organizations to define and enforce consistent security policies across the enterprise, ensuring standards are applied no matter where the code lives. At the same time, GitHub's dashboards provide centralized visibility into vulnerabilities at scale, giving security teams and leadership a clear view of risks and progress across the entire organization. So, some reasons to consider on why GitHub Advanced Security matters. GHAS shifts security left by embedding it directly into development workflows, so security becomes part of how teams build software every day. It automates vulnerability detection without the need for external tools, making integration and adoption seamless for developers. At the same time, it strengthens the software supply chain by securing dependency, and it reduces long-term security debt by helping developers identify and fix issues early before they grow into bigger problems down the line. By leveraging GHAS alongside complementary tools where needed, organizations can raise DevSecOps maturity, align with frameworks like OWASP DSOM, and embed security seamlessly into their development lifecycle. And because it's built into GitHub, it meets developers where they already work. All right, so we just walked through GitHub's features and how the DSOM can be used as the first step in your journey. So let's talk about reducing friction, as I think it's the most interesting part of this talk we're having today. Now, every organization approaches code deployment differently. Some rely on Jenkins or BuildKite, while others are using GitHub Actions. Many operate with monorepos, microservices, or a mix of both, each bringing its own set of challenges for security and governance. Layer on regulatory requirements, industry compliance frameworks, the possible complexity of recent on-prem to cloud migrations, and the landscape becomes even more difficult to navigate. The result is a unique combination of factors for every organization, which is why a cookie-cutter approach to enablement simply just doesn't work. The reality is that there's no one-size-fits-all solution. Every environment comes with its own mix of tools, workflows, and requirements. Each organization needs enablement that is tailored to its own ecosystem, not a generic checklist. Documentation and online searches can certainly provide a starting point, but they only take you so far. They rarely account for the nuances of your own CI/CD pipelines, compliance obligations, or development culture. What's often missing is the practical guidance and automation that translates theory into execution. In other words, the gap isn't in knowing what needs to be done, it's in doing it effectively and sustainably at scale. And this is where our experience comes in. Our role is to bridge the gap between documentation and real-world adoption by pairing open source scripting and automation with a guiding hand in a way that fits your unique ecosystem, whether you're running monorepos, managing microservices, or navigating compliance-heavy industries. Our approach removes the trial and error that often slows adoption, replacing it with a structured, proven path to maturity. This gives your teams the tools and confidence to remediate vulnerabilities faster, reduce risk exposure, and deliver code securely at the speed your business demands. By aligning automation with hands-on expertise, we help you achieve measurable security improvements while minimizing disruption to developer workflows. Excuse me. All right, so let's discuss 3 common scenarios that we've encountered throughout our enablement engagements. The first is tied back to what we've discussed in the beginning, which is where to start and how to know what to prioritize. And for that, we've created the DSOM baseline script. The DSOM baseline project applies the OWASP DSOM to GitHub environments, giving teams a structured way to measure and improve security practices. By automating those security checks against repositories using the GitHub API and CLI, it helps organizations quickly understand how their use of GHAS maps to the DSOM dimensions, such as build and deploy, implementation, and testing. Importantly, DSOM baseline supports multiple repositories at once, which gives enterprises a scalable way to assess security posture and set targeted improvement goals across their GitHub organizations. Results tie back to DSOM's maturity levels, highlighting whether a team is at a basic adoption or progressing toward advanced development. With YAML-based configuration and exportable reports, findings can be tailored, tracked, and integrated into your dashboard, turning GitHub data into actionable insights. And of course, this reduces that developer friction, accelerates your scanning maturity, and provides a clear roadmap for enabling GHAS in a way that aligns with both compliance and business goals. Now, we recently worked with a large electronics manufacturer who was at the beginning of their GHAS journey. They indicated that they knew where to go, but not so much how to get there or even where to start, which is a running theme today. We passed along the DSOM baseline tool, which they deployed, giving them actionable insights into what they were doing well and where they could improve. And by using the DSOM tool, they were able to develop policies to close those gaps and implement GitHub controls to enforce them. Additionally, because the DSOM tool provided clear insight, it allowed them to build a prioritized roadmap for rolling out those controls on a scheduled basis to minimize disruption. Now, the CodeQL Monorepo project was created in response to another enablement client that was using one GitHub organization with one massive monorepo. And just to quickly touch on a monorepo, they're repositories with multiple related projects. Each project often has differing programming languages as well as their own file structure. And this can pose a problem for the default CodeQL because it may produce insufficient results for compiled code, may miss folders down the line, down the file tree, and depending on the size of the monorepo, take an extremely long time to run. And this could be anywhere from tens of minutes to hours. We've seen both. Because of this engagement, the CodeQL Monorepo project is built for organizations managing large multi-project repositories. Traditional CodeQL scans, as I said, can be slow because they analyze the entire repo each time. So this tool speeds things up by scanning only the projects that have changed in a pull request or merge, while leaving unmodified projects untouched. However, teams can also schedule full scans of the projects when needed, ensuring baseline coverage alongside the targeted incremental scans. It supports both compiled languages like Java and C# with those build scripts that are stored in the build folder inside your .github folder, directory, and interpreted languages like Python or JavaScript that don't really need those special build steps. By running scans in parallel across multiple project folders, the approach significantly reduces CI/CD pipeline times while maintaining security coverage. And of course, everything integrates directly with GitHub Actions, so security checks remain in the developer workflow without extra tools or manual effort. Now, much like CodeQL for monorepos, our third script was developed in response to a problem we encountered with a client in the home security sector. Now, this particular client had a complex development environment that used multiple CI/CD tools, including Harness, BuildKite, and Jenkins for their legacy deployments. Because of this, dozens of person hours were spent installing CodeQL CLI into these pipelines, and dozens more hours were spent troubleshooting the integrations. The CodeQL wrapper provides a universal interface for running CodeQL analysis, making it much easier to adopt across diverse environments. It works with both monorepos and single repositories, removing a common challenge for enterprises with complex code bases. And because it's CI/CD and agnostic, it runs seamlessly in Jenkins, GitHub Actions, Azure DevOps, Harness, and other platforms, reducing integration friction. The wrapper itself includes smart language detection to automatically identify and analyze multiple programming languages in a project, including those compiled and interpreted languages, while that built-in Serif integration feeds the results directly into GitHub Advanced Security dashboards. That keeps the findings visible and inside the developer workflows. It also automates the installation and management of the CodeQL CLI, saving setup time and lowering the barrier to entry. With JSON-based configurations and performance optimizations like parallel processings, teams can scale CodeQL adoption across their projects with less effort. Now, ultimately, this reduces developer friction, accelerates the scanning maturity, and helps organizations realize gas value faster and more effectively. Now, because these projects are all open source, and you've already got the links there in the chat, you can explore them directly. You can visit the links shown here or click on the ones in the chat. You can fork or clone the repositories as you'd like and experiment with the tools in your own environment. Now, this not only lets you see how they work firsthand, but also gives you the flexibility to adapt and extend them to fit your own organization's needs. Now, one of the great things about GitHub is how easy it is to turn on advanced security and enable features at scale. But the reality is, every environment has its own nuances, and those nuances often require some fine-tuning. For example, maybe your teams are building in Java and Kotlin and need to configure advanced CodeQL for more accurate scanning. Or perhaps you're running self-hosted runner, which means you'll need to install and manage the CodeQL CLI yourself. Maybe your Python projects rely on private libraries that require additional setup. And in many cases, it's not just one of these challenges, it's a combination of several. And this is where having a guiding hand really makes a difference. Instead of struggling through trial and error, expert advice can cut down on the guesswork, accelerate enablement, and help your teams get the most out of GitHub Advanced Security. Even more importantly, it creates a structured path for moving up the DSOM maturity curve, transforming initial enablement into measurable, long-term security improvement. Now, let me share just one more story. We worked with a large retailer that was enabling GHAS across several thousand repositories spread across several dozens of GitHub organizations. Now, at first glance, it sounds kind of simple, just switch on GHAS everywhere. But the reality is far more complex. Each organization has its own CI/CD setup, and in their case, that meant BuildKite for pipelines and JFrog Artifactory for private artifact registries. The default GitHub configurations just weren't going to work out for them. Now, to address this, we built a dedicated script to integrate CodeQL with BuildKite pipelines across the organizations so that scans could run seamlessly without disrupting their development workflows. We also developed a script to apply and enforce a consistent GitHub configuration across all of their organizations, ensuring that security baselines weren't just recommended but actually applied at scale. Now, at the same time, we knew the technical rollout wouldn't succeed without developer buy-in, so we worked with their leadership to guide the rollout message, making sure the communication around GHAS was clear, actionable, and developer-friendly. One of the key nuances we uncovered was that they didn't want Dependabot flagging certain dependencies. Now, these versions were intentionally locked in place to support a handful of critical internal applications, and blindly updating them would have caused outages. On top of that, they wanted assurance that the automated updates from Dependabot wouldn't introduce breaking changes into production. Instead of a one-size-fits-all rollout, we helped them design a custom Dependabot configuration and then automated it so that it could be deployed consistently across named repositories via the GitHub API and expanded across the broader enterprise as needed. Now, finally, because automation at this scale requires authentication and personal access tokens would quickly hit API limits and pose security risks, we worked with them to set up GitHub apps. That shift not only provided a more secure authentication model, but also allowed their automation to operate with a much higher threshold for API calls. The result was a rollout that was technically sound, aligned to their environment, and sustainable for the long term. By combining structured guidance with automation, we helped them scale GHAS adoption in a way that matched the complexity of their environment. Instead of forcing developers to adapt to rigid security controls, we built workflows that integrated naturally into their existing pipelines, automated the enforcement of baseline configurations, and customized dependency management policies to fit their operational needs. This approach not only reduced developer friction, but also ensured that security became an enabler of business outcomes rather than a blocker, allowing their teams to deliver software faster while maintaining the right level of protection. So the final and arguably most important piece of this entire enablement puzzle is developer buy-in. Security at its core is a team sport. No matter how advanced our tools and automation become, they only deliver value if developers actually use them, trust them, and understand how they fit into their daily workflow. And that's why it's important to position security not as a gate that slows people down, but as a guardrail that helps them move faster and more confidently. We want developers to see these tools, code scanning, secret scanning, Dependabot, as partners that make their jobs easier and their code more resilient. The key to achieving that shift is communication and transparency. It starts with explaining the why behind what we're doing, connecting the dots between a security control and the risk it mitigates, or between a scan result and the business outcome it protects. When developers understand the reasoning, they're much more likely to embrace the practice. From there, it's about collaboration, making sure security teams and engineering teams are speaking the same language, working toward the same goals, and learning from each other. Now, training plays a huge role here as well. When we run hands-on sessions that walk developers through the tools they'll actually use, showing them how to use how a CodeQL alert maps to a real vulnerability, how secret scanning can prevent an accidental breach, or how Dependabot can automate dependency management safely, they start to realize that organizational security isn't something that happens to them, it's something that happens with them. And that's when culture begins to shift. By empowering developers with knowledge, context, and the right tooling, we transform security from a compliance checkbox into a shared responsibility, one that's built into the way they design, code, and deliver software. That's where real maturity takes root, when security becomes second nature and every developer feels like a stakeholder in keeping the organization safe. Okay, so while GitHub Advanced Security and the GitHub API provide significant coverage, some gaps may remain. These gaps may be filled using third-party GitHub technology partners, open source tools, Microsoft security solutions, and reviewing GitHub's evolving changelog for new features. Now, many GitHub Marketplace partners offer security-enhancing integrations that complement the DSOM assessments. For DAST enhancements, there's a partner called Stackhawk, and they offer dynamic analysis, or DAST, and API testing and discovery. Now, tools like this really help organizations expand scanning by testing running applications in real-world attack scenarios. For enhanced secret management, you have Azure Key Vault, which provides enterprise-grade secrets management that goes beyond GitHub's built-in features, which really helps organizations secure secrets across multiple repositories and environments. Using those technology partners, teams can bridge the GitHub API limitations and improve their DevSecOps maturity alignment. We can also fill those gaps with open source security tools and fill those gaps as well. So for threat modeling and risk assessments, you can use OWASP Threat Dragon, which supports threat modeling that really can't be measured through the API. For software composition analysis, there's OWASP Dependency Check, and then, of course, Endor Labs, which provide SBOM generation and vulnerability tracking beyond what Dependabot is able to do. And then looking at automated DSOM compliance checks, we can run Open Policy Agent related tools and InSpec. And these allow custom policy enforcement and security best practices. Now, by integrating open source security tools, teams can cover security domains not directly measurable through GitHub's APIs. We can also review GitHub's changelog for those future features, which GitHub is continuously expanding their security capabilities, addressing those DSOM gaps over time. And you can stay updated by monitoring, like I said, the changelog for those new security features and tracking GitHub discussions and community feedback for security enhancements. One thing that GitHub recently introduced that's in the changelog is incremental analysis for CodeQL, which only analyzes new or changed code rather than the whole code base. And then delegated bypass controls are enabled at the enterprise level for push protection, which just means you have more control over who can bypass a push protection rule by managing approvers. And then, by tracking GitHub's changelog, you can align future security assessments with upcoming features. Now, since GitHub is a part of Microsoft, security teams can enhance DevSecOps maturity by integrating Microsoft security solutions. You have Defender for Cloud, which extends the GitHub security insights across multiple cloud environments. Purview, which assists with compliance, data security, and risk management. Sentinel, which is super cool, integrates GitHub security logs for SIM-based monitoring and incident response. And I already mentioned Key Vault, which provides those secrets management complementing GitHub secret scanning. By combining GitHub security tools with Microsoft's ecosystem, you can expand their security capabilities beyond code repositories. So just summing up, today we explored how the OWASP DSOM provides a practical roadmap for improving security maturity, breaking practices into clear levels that can be measured and tracked. We then looked at how GitHub Advanced Security brings core capabilities directly into GitHub, like CodeQL for static analysis, Dependabot for dependency management, secret scanning, and SBOM generation. By mapping those GHAS features to the DSOM framework, organizations can identify where they're already strong and where more maturity is needed, turning security planning from guesswork into strategy. We also discussed how automation and expert guidance, such as scripting, repositories at scale, or building custom CodeQL support, can streamline adoption and accelerate those results. And finally, we covered how to plug the gaps by bringing in GitHub Marketplace partners, open source scanners, and Microsoft integrations like Defenders, ensuring your security coverage extends well beyond the native GitHub toolset. Now, this closes the loop from understanding the framework to applying GHAS to enabling it effectively at scale. Thank you so much for your time. You can reach me if you'd like at my email on the screen, or I'm on LinkedIn, so please reach out. Happy to talk with anyone. And thank you again.
Thank you all for joining, and thanks again to our speakers. This session is part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.